And welcome back. We are now going to continue our work with exception class today. We're going to look at a couple tips and we can use for when we're writing those exception classes. So first, let's review what an exception is. So remember, exceptions are unwanted or unexpected events that occur during the execution of a program that disrupt the normal flow of program instructions. These exceptions that are typically caught and handled by our program. Now, when an exception occurs within a method, this creates an exception object. And that exception object will contain information about what that exception is, such as the name, the description of the exception, and maybe even the state of the program when that exception occurred. Now, the major reasons why an exception occurs are typically things that we may or may not have seen. So, for example, invalid user input. That is something that we have seen quite often. Device failure. This may not be something that we have looked at right now, but it is something that you may have to have your program be able to handle. Like if your device fails, how does it handle abrupt termination, for example? A loss of a network connection. What if your device is communicating over the network and all of a sudden the network packet's dropped? How does it handle that drop of information? Is it going to try to connect? Is it going to simply just hold its state until it receives more information? How does it handle that? Physical limitations such as running out of memory, coding errors, or even opening an unavailable file, which of course we've seen when we worked a little bit with file input and output. Now, errors represent irrecoverable conditions such as things like running out of memory, memory leaks, stack overflow errors, and infinite recursions, etc. Now, errors, unlike exceptions, are things that are beyond our control, so we would typically try to avoid handling them. All right, exceptions, these are things that we can handle. Errors, these are a little bit more, you got to develop a better algorithm for. So, for example, if you're looking at like infinite recursion, did you develop an algorithm that's going to be handling that correctly that you don't run into that as an error? Now, there are, of course, two types of exceptions that we've looked at, which are built-in versus user-defined. Now, the built-in exceptions are the exceptions that are available within the Java libraries, and they're usually used to explain certain error situations. And they are broken down into either checked or unchecked exceptions. Checked exceptions are the ones that will check your code at compile time, whereas unchecked are the ones that looking for that throws of an unchecked exception. And whether or not we handle it or not, that's the program will not give a compilation error because that's not what it's designed to do. It's not designed to run at compile time. In comparison, the user-defined exceptions are designed to handle situations that are not defined by any of the built-in Java exceptions. Now, there are some key points to remember when we're working with exceptions. First off, in a method, remember, we can have more than one statement that might throw an exception, but we want to put these statements with their own try block and provide a separate exception handler within their own catch block for each one. So every time you have a try block, you should have its own unique set of catch blocks. Now, if an exception occurs within a try block, that exception is handled by the catch block associated with it. Now, remember, you can have more than one catch block. So, for example, you might have the generic exception block to handle it, or you might have a specific exception. Now, each catch block, of course, is an exception handler that handles the exception to the type indicated by its argument. Now, we will, of course, later look at another block, which is known as finally, but add yet another mechanism to our try-catch approach. Now, when should we actually use an exception? What are the things we need to actually look at that? So, the thing you have to remember is that we don't always need to handle exceptions within our programs. It really depends on the specific case of whether or not we should handle or specify an exception. There's not really a one-size-fits-all recommendation that's a good fit for all cases. But in general, we can use the following question to determine if exception needed. Can you handle the exception within your current method? Can you anticipate the needs of all users of your class? And would handling the exception fulfill these needs? If you answer yes, well, then you should try to, instead of using a try-catch approach, just use your current method and not necessarily implement those exceptions. In all other situations, though, it's better to specify it to allow the caller of your class to handle it with some implementation that fits that current use case. Now, why do we need exception handling? Well, the primary reason is a lot of times user experience, like the end user, not of course the programmer, but let's say a program crashes unexpectedly without proper handling. Well, that's going to be a pretty poor user experience. The end user is not going to be happy that their app just crashed on them, for example. Resource management is another common thing while we might use exception handling. Proper handling can ensure that resources like files or network connections are closed or released correctly even when an error occurs. We've seen this a little bit with our try-catch when we talked about file input and output and using things like file.close to ensure that those memory resources are actually properly secured. Error diagnosis. This is a huge one. Exception handling, of course, by its nature, gives us detailed information about where and why a particular error has occurred, making it a lot easier to diagnose and fix. We don't have to comb through our program and look specifically with a bunch of print line statements or tracing and stuff like that, because we can use that exception handling, say, hey, it was triggered by this particular thing. How do we handle it? And of course, robustness. This allows us to have robust programs that are going to handle unexpected situations during runtime, because let's face it, we necessarily can't always anticipate every kind of thing that's going to occur with our program. And so having exception handling is a great way to help factor that in. All right, and if we look over in Eclipse, I have this quick exception. It's called a negative number exception. You can see it's a very basic exception here. But if I look at my program here, what is that negative number exception actually doing? Well, if we look at it, it's looking to see if the input here is less than 0. It's just simply going to throw this negative number exception. Now, this is where we start asking that question of, can we take an exception and use it? Do we actually need it? So could I rewrite this program but without an exception? And the answer is quite simple. We could. So let's just go ahead and just see this with the comparison. So I'm just going to go ahead and create this same lab here. So I'm just going to call this V2. And let's throw that main in there. And what I'm going to do is I'm just going to go ahead and grab over my scanner. And let's just grab the other items here. So I'm just going to grab these same things here and implement those in. Oh, put those inside. Grab the main. Paste that in. All right. Now, let's go ahead and do this and look at what is this program actually doing. Well, if you think about it, it's simply just checking to see if it is less than 0. And then what we're trying to do is loop it back to get new input. So I could, of course, do all this. In fact, I could probably eliminate this try again method here. So let's just go ahead and take these out here for a second and think about what we're trying to do. Well, we're trying to get a positive number, and we're going to go ahead and get that from the keyboard, and then we're using a conditional statement to go ahead and test that. So I'm just going to remove this statement here, and what we want it to do is, if it's less than 0, we can of course just simply prompt system.out.println that is not a positive number. Please re-enter a new number. And that, of course, is the foundation for what we need. And we could, of course, just put this inside of a loop. So let's just go ahead and put our loop right here. So we can just do a while, and we can say is number. And so we're looking for to see if the number is positive. All right. So while that number is negative, we're going to, of course, loop. And let's just go ahead and set that equal to true. So while that one is true, so is number negative. And let's go ahead and isolate this within a loop. And of course, I need to define what is number negative is. And so if you look, it's like, I don't know what it is. So let's go ahead and add that as a variable to our program. And we'll just set that equal to true just to start. And it needs a type, so we're going to make it a Boolean. And then what we're going to do is we can say is number negative, and we can change that to false. All right, based upon if at that point this number gets changed. It looks like I moved this, and let me just move it back down. There we go. And so if at any point we get this to be correctly, now I do have to change this a little bit here because I'm assuming that this is going to, of course, want to loop. We want to have this fall out. So I'm going to go ahead and change this. So let's move this. Actually, I want this print line statement to be below this if statement. All right. And so what this is going to do now, it's going to say, hey, I'm going to get an input from the user. I'm going to say, oh, this is going to be greater than this, so we can change the false. The other thing I could do is I could just do a break statement here and just simply use that to fall out. So I wouldn't even necessarily need this loop. I could even just do a while true here. So there's multiple ways that you can carry out this implementation. All right, but I'm just going to have it loop, and I'm just going to say, hey, if this is greater than 0, I'm going to break out the loop. And then, of course, I can then print out the number. So if we go ahead and run these programs here, so enter a positive number. So I'm just saying -4. We get that's not a positive number. -3, not a positive number. Let's do 5. Boom, it prints out the number. If I look at this one, we kind of have the same thing. Now, I don't have this one quite looping here. We'd have to do a little bit more implementation, but it has the same basic structure. So if we put -4, you can see it loops back around to the try again method. And then, of course, we could try entering in 5, and then we get a positive number here. So this one, of course, doesn't have quite the same loop. I'd have to have another call in here for that method to call itself. So that would, of course, be a pretty easy thing to do. I could just add try again in here. But you get the basic structure here between them. And, of course, one thing you can see is that when we are looking at this one, this is a point where we're using exceptions, and it does add some more robustness to our program. But we, of course, can also handle that same thing necessarily without needing the exceptions. So we don't always need to implement exceptions. That's one thing we want to make sure we iterate in this lesson, is that you don't always have to have a strong level of everything with exceptions in order to have a good program, because sometimes exceptions aren't needed. But there, of course, are times when they are needed, and as we've seen with some of our other exceptions that we've looked at, they can be very useful.